Welcome to Climate Change and Health in Small Island Developing States focused on the Caribbean. If you require translation into Spanish or French, please use the link posted in the chat and choose your desired language at the bottom of the screen. You should continue to keep this browser open as well to utilize the Q&A feature in the chat panel. Please be sure to scroll down and hit the mute on the video. Please use the Q&A feature to submit any questions you have for the panelists. This session is being recorded. Thank you.
Good day, everyone. My name is Marvin Reed. I'm the Deputy Dean for Research at the University of the West Indies on the Mona campus. And it's indeed my pleasure to welcome you to this conference on climate change and health in small island developing states. This session, session 1, will focus on air quality challenges, Saharan dust and fossil fuel. To help us understand the issues around this some more, I have 3 speakers this evening, Pablo Mendez Lazaro, Andrea Seeley, and Kishan Kumar Singh. So I'll introduce to you Dr. Mendez Lazaro, who is the Associate Professor of Environmental Health Department, the Graduate School of Public Health at the University of Puerto Rico Medical Science Campus. And he is one of the 6 scientists nominated by the governor of Puerto Rico and confirmed by both the Senate and the House of Representatives of Puerto Rico for the Executive Committee on Climate Change Adaptation Plan. He's currently the PI co-PI on several research projects, the major one of which is sponsored by NASA, which seeks to apply Earth observing data to research on public health and vulnerable population. He will be followed by Dr. Andrea Seeley, a meteorologist at the Caribbean Institute for Meteorology and Hydrology here at the University of the West Indies. She's also the supervisor and advisor for the committee for a number of PhD and MPhil students, both in meteorology and environmental studies, as well as the chair of the Pan-American Regional Steering Group of the World Meteorological Organization, Sandstorm and Dust Warning Advisory Group. She will be followed in her presentation by Dr. Kumar Singh, who would be speaking on the health benefits of improving air quality through mitigation and adaptation. He has been the lead Trinidad and Tobago climate change negotiator for the past 23 years and has held various leadership positions internationally, including chair of the expert group on technology transfer and the chair of the subsidiary body on scientific and technical advice to the United Nations Framework Convention on Climate Change, as well as a co-chair of the ad hoc working group on the Durham Platform, which was a body charged with negotiating the Paris Agreement in 2013 through to 2014. So colleagues, we have a rich degree of expertise to help guide us on this afternoon's topic on air quality challenges and Saharan dust and fossil fuels. So it's indeed my pleasure on your behalf to invite Dr. Lazaro to present first.
Thank you, Marvin. Can you hear me?
We're hearing you good.
Yeah, and can you see my screen as well?
And screen is good.
Perfect, thank you. So good afternoon, and thank you for inviting me. For me, it's a pleasure to be here, and thank you for the organizing committee. I'm very happy to be part of this initiative. It's an excellent initiative for the Caribbean, talking about these topics. As Marvin mentioned, I'm Pablo Mendez Lazaro. I work at the University of Puerto Rico Medical Science Campus, but the Environmental Health Department. And I'm going to be speaking about Saharan dust, like a natural source of air pollution in the Caribbean. On November 2017, we gathered a team together composed by epidemiologists, climate scientists, atmospheric science, environmental health, and different professionals. And we propose research to NASA to characterize the distribution pattern and variability of Saharan dust, but also using Earth observation data, ground-based station, and to quantify the impact on respiratory diseases over Puerto Rico, using Puerto Rico as a proxy for the Caribbean islands. The main goal, after analyzing the impacts using Earth observation data and quantifying and characterizing the Saharan dust using ground-based stations, was to develop, or is, because we're still working on it, is to co-design public health early warning system, at least for Puerto Rico and the US Virgin Islands. To do that, we started working with almost 19 different organizations since the very first beginning, organizations that are related to health science, public health, but also organizations that are related to the atmospheric science, remote sensing, and weather services, for example. So with different stakeholders, practitioners, and also physicians and medical doctors in different parts of Puerto Rico, in the continental US, and in some cases in other parts of the Caribbean, as it could be, have been collaborating through our colleague, Dr. Olga Mayol and Dr. Andrea Celi with the Caribbean Institute of Meteorology and Hydrology. What is the Saharan dust and its season in the Caribbean? So these are mineral dust particles that are arriving to the Caribbean region after being transported for 7,000 kilometers through the atmosphere, arriving to the region. And it could contain minerals and organic matters, marine salt, viruses and bacteria, calcite, sulfates, and others. So this is like a bunch of, there's aerosols, right? So aerosols are small liquid particles that are suspended in the atmosphere. And some of them are literally organic matter that are coming from the soil of the desert in Sahara and the Sahel Desert. These dust clouds are positive for the environment because they're providing also nutrients to the terrestrial ecosystem, but also to marine and coastal ecosystem. But in the other part is that it could be a threat to public health and represent a hazard for vulnerable and sensitive groups that have already chronic diseases or because it's affecting respiratory system. The season in the Caribbean is mostly associated with the summer of the Northern Hemisphere in our region. So most of the episodes occurs during June, July, and August, although we can receive some pulses or dust clouds that could arrive our region out of the season. For example, we have been suffering a couple of them recently, and we are in October. So it can occur during the whole year, but the peak season for Saharan dust is during the summer of the Northern Hemisphere, and we can see here in this graphic. The arrival of Saharan dust is associated with an increase also in PM 2.5, and therefore also it could represent a potential risk to public health, and it's associated with cardiovascular and respiratory conditions in the Caribbean. In Puerto Rico, it's positively associated with hospital admissions and asthma conditions in Trinidad and Tobago, in Guadalupe, and Grenada. And this particulate matter could be small enough, not necessarily to go very deep into the health system, but it can irritate the part of the first part of the respiratory system, nose, lungs, and those kinds of those parts of the respiratory system. During the summer of 2020, when we were dealing with the lockdown because of the COVID-19 virus that is obviously affecting the respiratory system, we also suffer in the Caribbean region one of the worst events associated with the arrival of Saharan dust. And it lasts, at least in Puerto Rico, for 3 consecutive days with unhealthy situation and conditions due to air quality, poor air quality in Puerto Rico because of the PM 2.5. And the visibility also went down for almost 3 miles when the normal in Puerto Rico could be 10 to 9 miles, and it could go up to 20 in some cases when we have clear skies. These are 2 examples of images that we took right before the Godzilla dust event arrival to Puerto Rico. One is in the southwest of the island, and the other is in the northern part of the island. So taking advantage of this situation was an historic event. We knew it at the beginning. We were unable to have access to the health data. So we submit a survey aiming to assess the impact of the Godzilla dust event on the Puerto Rican population. Almost 1,500 people participate, and 90% of them are affected and were affected by this dust cloud. At least 65% of them had at least one chronic disease, meaning that they have a pre-existing health conditions, and almost 60% out of them reported that the worst situation was with asthma. And there were some other mild conditions associated with postnasal drips, cough, right and eye irritation, shortness of breath, and fatigue. Due to that, we're working on the developing of the early warning system, working with the Department of Health and the National Weather Service, NASA, and some other agencies in Puerto Rico. And we started to identify threshold for the arrival of this aerosol to the region and for Puerto Rico. And we're using a platform that is in CARICUS. CARICUS is the Caribbean Regional Coastal Observance System that is part of the University of Puerto Rico in Mayagüez. And we are providing at least information at the atmosphere level that in terms of the concentration of aerosols arriving to the island. Not concentration, aerosol optical depth. We can go into the details of the methodology later. In collaboration with the Department of Health, the Department of Health is issuing some warnings and infographics in order to advise the population and also providing protection measures and preparedness. And in collaboration with the National Weather Service and Ecoexploratorio, which is an NGO with education in Puerto Rico, we are providing workshops and in order to provide educational materials to the population. For more consideration, we believe that for a better understanding of how these dust cloud effects are affecting the population, we need to provide a better tool to the decision makers and practitioners in Puerto Rico. And also we believe that this early warning system using Earth observation data are very useful for practitioners, stakeholders, and end users in order to make decisions that can help to prepare, mitigate these potential effects of dust related illness in Puerto Rico. Thank you so much for this opportunity. And again, I'm looking forward to answer questions when we can in the other section. Thank you.
Thank you so much, Dr. Lazaro. It is indeed my pleasure now to welcome to the mic Dr. Seeley for her presentation.
Thank you, Marvin, and good afternoon, everyone. It is a pleasure indeed to be here and to share with you in terms of forecasting dust and air quality in the Caribbean for better health. So I firstly want to leave a statement with you. And this says, sand and dust storms have become more frequent in this region and other parts of the world. But armed with the knowledge, tools, and resources, we can adapt to and mitigate their impacts. And I'm sure much of the discussion after our presentations will be focused on this. And models are a part of that. But before I go on to talk about the modeling, I want to put the research behind Saharan dust in context, globally and also for this region. The University of Miami Atmospheric Chemistry Station, which was implemented by Professor Joseph Prospero, Professor Emeritus at the University of Miami, has been measuring dust on the east coast of Barbados since 1965. It is the oldest, longest dust record globally. And Professor Prospero over the decades has done a lot of research. And you would notice that I have two charts up. On the left-hand side, we have Barbados dust annual means. And you would see from the chart, the amounts of dust have actually increased significantly since the 1960s, the Saharan dust. And it has continued to be moderate or moderately high levels of dust since then. It has stabilized. But the interesting thing about it is that the dust transport we get now is more than we have gotten in the past, much more than we've gotten in the past, and significantly more so. If you look at the diagram on the chart on the right-hand side, you would see that this is dust for 2012. And this was an experiment where they wanted to see the particulate matter that was present in the dust. This is not shown here, but what we have here is PM10. But there was also work done in terms of PM 2.5. And the overwhelming amount of dust or the overwhelming amount of particulate matter you get in the Saharan dust coming across to our region is PM10, and a significant percentage is PM 2.5. If you look at this record here from 2012, you would see that the days where we have significant dust incursions exceeded what at the time was the World Health Organization, WHO, PM10 guidelines for good air quality as measured in terms of the particulate matter 10 microns or less. So we know that dust incursions do significantly degrade air quality in our region and in regions where we have dust storms or dust incursions or dust episodes. So it really is important to be able to forecast these dust incursions. And at CIMH, we are one of the institutions that have been working on that for the past few years. We have a dust and air quality forecasting center where our model being used is the Weather Research and Forecasting Model with Chemistry, WRF-Chem, version 4.1.1. We've initialized with certain types of radiation from Goddard, so the go-kart model, Goddard chemistry with aerosol, radiation, and transport. We cycle it daily, and we also use the global forecast system with a 0.25 degree resolution, and we run our model twice a day at 0Z and 12C. Our domain size is 27 kilometers, and our domain extends from northern South America up to the subtropical areas of the Greater Caribbean Basin. We also run out as far as Central America, the Yucatan Peninsula, and as far east as the source regions in North Africa. So from about 2 degrees south to 36 degrees north and 45 degrees east to 90 degrees west. And these forecasts are 7-day forecasts. So it's a coupled weather dispersion air quality model with full interaction of chemical species, and we predict dust, aerosol optical depth, which gives you an idea of how many particles are in the air as well, another measurement for that, and PM 2.5 and PM 10. In addition to that, we do ozone as well. We forecast ozone as well. So what I wanted to talk about as an example of forecasting a dust event in advance is the 2020 Godzilla mega dust event that Pablo talked about in his presentation. If you look at the diagram on the left-hand side, this is from Barbados, and this is in St. Michael, one of the southwestern parishes, and the parish where the capital of Bridgetown is located. And this picture is taken looking north along the ABC highway, and you would notice that you cannot see much further than a couple of kilometers, a few kilometers at the most inland going north. And if you look on the right, you will see the satellite imagery. This is GOES geocolor, GOES East geocolor. And you can see that for the Godzilla dust event, the extent of the dust, the intensity is high, but also the spatial extent of the dust the range is pretty large, which shows that this dust episode did plague the Greater Caribbean area for days, a number of days. The next diagram, or the next slide, I should say, shows 4 maps or 4 videos. And this shows our model output. In the upper left-hand corner is the Saharan dust concentration. The upper left-hand corner is the AOD, aerosol optical depth. And the lower left and right-hand corners are the PM 2.5 and PM 10 concentration, respectively. The model was initialized on June 18th, 2020. So this would be the forecast. This would give the forecast 7 days in advance and this would encompass the time period where the dust episode would have been plaguing the Greater Caribbean and the dust being transported to the southeast US and the Gulf coastal states of the US. And the most intense colors for the parameters you see are oranges and reds. And you can see the transport from the source regions in Northern Africa and showing the dust event beginning to affect the Caribbean around the 19th, 20th and continuing into the 24th and 25th, where the most intense dust plume would have reached the US. So the model is a useful tool for actually predicting dust incursions. We need to do more validation in terms of how the amounts compare to observations, but we do know the model did pick up the arrival of this intense dust plume and more or less was able to predict its duration and its extent. So to summarize the WRF-Chem predictions, the model forecast that was initialized June 18th shows moderate to high dust concentrations affecting the Eastern Caribbean between June 19th to 20th. These concentrations were expected to reach the northwestern and western Caribbean between June 21st to 27th. And by June 22nd, 23rd, in the Eastern Caribbean, we had the most intense area of the dust plume, and then the core reached the West and Northwestern Caribbean later. And this is reflected in the AOD PM 2.5 and PM 10 forecasts. The peak surface dust concentration was forecast at greater than 400 micrograms per meter cube, which is very high, and the aerosol optical depth greater than 1.5. The highest we usually see in dust episodes is about 0.9, 0.8, 0.9 to 1 in terms of AOD. So a big part of what we do in terms of the work that we are doing at CMH, we are part of the WMO SDSWAS, as Marvin mentioned in his bio that I had provided. And this is a WMO initiative to establish a coordinated global network of sand and dust storm research and forecasting centers. And the Regional Center for the Americas is hosted by CIMH. So this is a big part of our portfolio and what we do. And this initiative aims to enhance the ability of countries to deliver timely and quality SDS forecasts, observations, information, and knowledge to users through an international partnership of research and operational communities. So along with the Regional Center for the Americas, there's a Regional Center for Asia and the Regional Center for North Africa, Middle East, and Europe. And together, we are aiming to deliver our quality SDS forecasts. We are aiming to offer these tools and resources to the global community in terms of predicting the effects of sand and dust storms in advance. There are also 2 operational centers, and these are at Barcelona and Beijing, and we hope to establish one in the Americas within the next few years. So I would like to thank you for listening, and I look forward to our discussions. The contact information here is for myself and the team, including the principal of CIMH, and I can make this information available upon request. Thank you very much, and I look forward to our discussions.
Thank you, Dr. Seeley. Excellent presentation. And I will now hand the baton, so to speak, to Dr. Kumar Singh, who will speak about the health benefits of improving air quality through mitigation and adaptation.
Thank you very much. And thank you to the organizers for inviting me to take part in this very interesting seminar and topic. So I will deal briefly with the health benefits of improving air quality through mitigation and adaptation to climate change. In keeping with the instructions, I'll try to keep within 10 minutes. I have a lot of slides, but it's only for completeness, which can be shared for future reference by those who may want to have a reference to it. So I start with air pollutants. So according to the World Health Organization, air pollution is now considered one of the greatest environmental threats to human health. And it kills about 7 million people each year and is linked to an increasing number of health impacts. And of course, increases the susceptibility to COVID-19, the so-called comorbidities. But air pollution is also responsible for driving environmental change, such as climate change, which in itself, when is manifested, will also have direct and indirect negative impacts on human health, including increasing heat and health susceptibilities to those impacts, such as cardiovascular and respiratory ailments. The pollutants also impact air quality, as we know, food, water, and economic security. And as a result, their negative effects on public health, agriculture, and ecosystems are well known through their indirect impacts via the impacts of climate change. The usual suspects for climate change are the so-called greenhouse gases, the carbon dioxide, methane, nitrous oxide, and fluorinated gases. But I would want to focus a bit more on the climate forcing air pollutants, the so-called short-lived climate pollutants, or the SLCP. These are powerful climate forces that remain in the atmosphere for much shorter period than than carbon dioxide and has a greater potential to warm the atmosphere, and is currently accounting for about 45% of the current warming of the atmosphere. And they are classified as black carbon, tropospheric ozone, and hydrofluorocarbons. These short-lived pollutants are dangerous air pollutants because they have adverse health impacts and responsible for premature deaths arising from heart and lung diseases, strokes, heart attacks, chronic respiratory diseases such as bronchitis, asthma, and other cardiorespiratory symptoms. The WHO estimates that between 2030 and 2050, projections of climate change will cause hundreds of thousands of additional deaths arising from impacts of climate change, such as malnutrition due to food security and agricultural decrease production, malaria, diarrhea, and heat stress alone, malaria and diarrhea being vector-borne diseases that will arise from a more favorable climate for proliferation. And that there's growing evidence that exposure to air pollution also increases susceptibility to the serious complication and death arising from COVID-19. So it's a bit of a multiplier. These short-lived pollutants, this diagram basically shows the sources and the lifetime in the atmosphere and the levels at which they persist. So black carbon, methane, tropospheric ozone, and hydrofluorocarbon. Black carbon really it comes from the incomplete combustion of fossil fuels, is also known as soot. And a huge component of that is particulate matter. Once it is emitted into the atmosphere, it is also emitted with a complex mixture of air pollutants, among them being volatile organic carbon compounds. Methane has its source in human activities, such as natural gas systems in the fossil fuel industry, as well as from livestock production. Natural sources include wetlands and rice production. It has a huge global warming potential, or a huge potential to warm the atmosphere many times more than carbon dioxide. Hydrofluorocarbons are man-made entirely. They are not naturally occurring, and they are used widely in air conditioning and refrigeration, in solvents, in extinguishing systems, and aerosols. Although they're a small fraction of the current greenhouse gas emissions, they have huge greenhouse warming potentials. A greenhouse warming potential means that one molecule of methane, let's say, that has a greenhouse warming potential of 24, it means that one molecule of methane will warm the atmosphere as the equivalent to 24 molecules of carbon dioxide. And these HCFCs have global warming potentials in the thousands and tens of thousands. Tropospheric ozone, as we know, is a major air pollutant formed by the interaction of sunlight with hydrocarbons and nitrous oxides. And the usual culprit, fossil fuel power plants, tailpipe emissions, refineries, and other industries. Because when hydrocarbons, VOCs, mix with nitrous oxides in the presence of sunlight, they produce this tropospheric ozone. So given the global warming potential of these gases and the health impacts, of course, reducing them will not only have positive impacts on the climate, positive benefits on the climate, but also on human health. And the UNEP and WMO have identified various control measures that can achieve at least 90% of these total potential emissions reductions for these gases. And they have estimated that most of them are cost-effective technologies that already exist. And if quickly implemented, these measures can cut the amount of warming that will occur in the next few decades by as much as 0.6 degrees, while avoiding 2.4 million premature deaths from outdoor air pollution annually by 2030, and preventing 52 million tons of crop losses per year, which will indirectly contribute to food security and so on. So some of the measures include for agriculture, where methane forms major emission of greenhouse gases, to improving manure management and animal feed quality, applying intermittent irrigation of continuously flooded rice paddies, improve selective breeding to reduce emission intensity and increase production from animals, because they burp these gases, methane in particular. And of course, promote farm scale anaerobic digestion to control methane emissions from livestock. In terms of fossil fuels, of course, reducing leakage from long distance gas transmission because methane is natural gas. Extending recovery and utilization from gas and oil production and recover fugitive gas emissions for reuse or for flaring. In terms of waste management, of course, waste is a prime source. Waste management is a prime source of methane. So some of the measures include collecting and capturing landfill gases, upgrading water treatment plants with gas recovery technology. The list is there, I wouldn't go through all of it. Black carbon, of course, in the household energy, I don't think much of this remains in the Caribbean, but I just put it in for completeness, where you have cooking with wood or use of kerosene lamps and so on should be avoided or replaced. And in terms of industrial production, modernizing traditional brick kilns to vertical brick shaft brick kilns so that you maximize aviation and therefore complete combustion. And in transport, of course, switching to cleaner alternative fuels such as biofuels or compressed natural gas, switching to electric vehicles and prudent and efficient traffic management to avoid buildup of tailpipe emissions that will give rise to other pollutants, not only nitrous oxide and VOCs, which have direct health impacts, but also secondary pollutants that are formed, such as ground level ozone. And of course, banning open field burning of agricultural waste and banning open burning of municipal waste, capturing and improve flaring and gas production are other ways in the different sectors that can be used. And of course, hydrofluorocarbons in the cooling sector should be addressed upon execution of policies under the Kigali Amendment to the Montreal Protocol. And these are some of the measures that can be used. We heard some of the impacts of Sahara dust, and I see some questions and comments coming up in the chat. The Saharan dust has been around for thousands of years, albeit in different concentrations and different intensities. But there's a curious relationship now with climate change and Sahara dust, because NASA, for example, projects that with increasing atmospheric and sea surface temperatures, Saharan dust visitations will be less. We know that Sahara dust not only has adverse impacts on health, we saw some of that in the earlier presentations, but it is an important source of nutrients for agriculture and for marine systems, because the Saharan dust contains a lot of nutrients, particularly iron and phosphorus. And it is projected that with global warming and increasing in sea surface temperatures, because the wind speeds are directly dependent on sea surface temperatures, because we know warmer temperatures feeds hurricanes, for example. When this temperature increases and the northern Atlantic warms relative to the southern Atlantic, the northeastern trees that we know that blow dust from east to west will become weaker. And as a result, the slower winds pick up less dust to be transported from the Sahara Desert to the Caribbean and the Western Atlantic. Thank you very much. I thought I would have kept it within my time. A lot to squeeze in, but happy to answer any questions. Thank you very much.
Thank you so much, Dr. Kumar Singh. And indeed, we have had a range of presentations so far, looking at starting with the Saharan dust, looking to see whether or not we could forecast it, as well as having a brief discussion on other forms of pollutants that affects the atmosphere. So we do have some questions that have been posed to the panelists in the chat. What I would do, though, as I go through these questions and share them with the speaker, I just wanted to ask one bit of question. This is more addressed to Dr. Seeley. Do you foresee us coming to, just like we have hurricanes and we name hurricanes during the course of a season, do you foresee a similar sort of activity for the Saharan dust plume? or it wouldn't make any sense?
Not at this point. I could only see what we did with the mega dust plume we had last year, giving it a nickname perhaps, but nothing structured like what we have for tropical cyclones at this time.
Okay.
Last year's was Godzilla because it was huge. So does it name the scientists? Everyone, including the scientists, have adopted.
Okay, fair enough.
Yeah.
So I'll start by just reading a few questions from the chat, and I'll start with the last one first. So this one says, do you think we should have health warning labels on gasoline and diesel fuel pumps in service stations? I think this one is more for Dr. Kumar Singh.
Thank you for the question. Yes, indeed. In fact, most modern service stations actually have these fugitive emissions traps at the end of the nozzle, well, at the beginning of the nozzle rather, so that when you insert the nozzle into the gas tank, there's a sort of a rubber cap that should fit neatly over your gas tank opening that will actually trap any of the fugitive emissions that will come out as a result of the pumping of the gas or the diesel, because they're volatile compounds. So it is, I think most modern gas stations already have those things, outfitted in the nozzles that dispense the vehicle fuel. So, I mean, it's not perfect. I would not imagine that it's 100% efficient. So I do take the point that perhaps maybe some warning signs could be posted, at least to be aware, because I'm not sure that the exposure time, coupled with the mitigation technology of the fugitive emissions trap, will expose you long enough to perhaps have any immediate adverse effects arising out of these fugitive emissions. But certainly, maybe over prolonged periods, they can cause some health issues. But I'm not sure what those anyway. But I take the point.
Sure. Thanks so much for that response. Dr. Lazaro, I know you're more on the physical science side, but here's a question from asking you. Do you have any examples of the types of viruses and bacteria that may be associated with the dust, and how may any of these microorganisms affect health?
Yeah, perfect. Thank you. I would like to say that sometimes when we're thinking about this aerosols coming to Puerto Rico, not to Puerto Rico, to the Caribbean from the Saharan Desert, this is like a piñata, literally. This could contain silica, dust, and organic matters, but also these kind of bacteria and pathogens. There are a few studies that have been published in one of the best journals of the United States in AGU, GeoHealth, and they were able to make different characteristics and analyze the different bacteria inside of this dust arrival to the Caribbean. And one of them was Burkholderia cepacia, Pseudomonas aeruginosa, and they are associated also with respiratory and lungs issues. I'm not a physician to tell you how bad could it be or represent for patients or for sensitive groups, but at least there is evidence enough to believe, not to believe, suggesting that there is indeed bacteria and pathogens flying in all together with this organic matter. Yeah. Again, I think that we should think about this dust cloud not only as dust, but also like a piñata. Full of different aerosols are coming inside of this dust.
Sure, thank you so much.
That's why it's so difficult.
Right. There's a question here which I think is rather interesting. Does the Saharan dust have a particular signature? How can you distinguish a P10 particle and a P25 particle, whether or not it's coming from the Saharan dust or any other source? Is there a particular signature that you as scientists can actually use to say it's coming from the Sahara?
I could take that one. I'm
Sure.
not a chemist per se, but the people we work with, both Pablo and I, are chemists. And what would be done is that the samples would be taken from the observation site, and then they would do chemical analysis, and they would be able to tell you it's Saharan dust. Now, the interesting thing about it is that most of the time, you could almost say even before the chemical analysis is completed that you know that it will be Saharan dust, because, for example, if you look at where the station is in Barbados, it is on the most easterly point in Barbados, which is Ragged Point. So that station that I mentioned in the presentation that is managed, or that has been managed by University of Miami for the past over 50 years, that any particles coming across would more than would almost definitely be Saharan dust, and would not be a source from within the locality that you're measuring, because that station is on the east side of the island. So you would not be contaminated by any local sources of PM 2.5 and PM 10. So you're almost certain any spikes in PM 2.5 and PM 10 that you get out there generally would be Saharan dust.
Maybe I could just quickly add, because I'll join the group of chemists as a chemist myself. Most times geological material have a signature in terms of the ratios of the various elements that they have, whether it's aluminum or silica. And that can be distinguished, for example, from sea spray, where the ratios of sodium to other elements are fixed. So you can actually distinguish from a filter, if you take a sample, what portion is actually dust and where it comes from, and what portion is actually from sea blast as we know it. So there are chemical approaches to do that.
Okay, excellent. Thank you so much. The other question is, I think you alluded to it, Dr. Kumar Singh, in your presentation. Some respondents, attendees are suggesting that some recent data suggested that the frequency of the Saharan dust plume is likely to decrease because of the general warming of the Earth. Would you wish to comment on that?
Yes, I did mention it, I think, in my last slide in the presentation. Right. The projections actually signal this change or likelihood going forward, because with changing sea surface temperatures and changing ambient temperatures, remember, these are the things that feed hurricanes and winds. And therefore, with increasing sea surface temperature, there is likely to be a disruption in the northeasterlies. And therefore, the carrying potential of Saharan dust across the Atlantic to the Caribbean and South America, and of course, North America. So it is projected that with increased warming of the sea surface and ambient temperatures as well, in the North Atlantic in particular, that it is likely that the visitations will be reduced in the future going forward.
Sure. Dr. Seeley, as the most easterly of the Caribbean islands, do you foresee N95 marks being a basic household requirement in the near future?
Could you repeat? Could I see? I missed part of the question.
Do you foresee household, just like as part of the hurricane seasons, at the beginning of the hurricane seasons, we give a list of essential items that people should stock up on in preparation for the hurricane. Do you foresee, especially in Barbados, as you're the most easterly, that respiratory mask may become one of those essential list of items that you advise the public to invest in?
I could actually see, I don't know if I would say it's as, for some people, I should say, it's not as urgent as what we would say for hurricanes, but given the fact that what we are working on now in the community is having these early warning systems, and right now most of them are weather time frame, which is like 7 days, 10 days in advance, but we also have seasonal dust forecasting as well. And I can actually see us moving towards looking at the fact that based on a short-term climate forecast or an intra-seasonal forecast, we can say, well, it may be more dusty for the next 3 months, next 2 months, and this is what we need to have. And not only in terms of respiratory masks, but also what stock pharmacies would have and what doctors may have to look out for, because they may have more patients coming to them complaining about allergies, etc. You may have more people may need to be nebulized, etc. So I can see us moving towards sending out information, or at least sending information to the health stakeholders, so they can actually send out advisories in terms of what the upcoming dust season may look like and what you should have in stock and on hand for that period of time. So I can see something along those lines happening. And that's the purpose of having the early warning system, because you want people to have a heads up and to mitigate the effects later on.
If I can add quickly, with your permission, in Trinidad, for example, you have a network of air pollution monitoring stations, and actually Saharan Dust is now part of the weather forecast every evening, and that is now mapped to the air pollution monitoring system, and therefore there's an index of good or moderate, and who shall be affected most, and what to look out for, whether to stay indoors, and so on and so forth. So that helps, because I know there was another question of a connect. I know it helps because some members of my family have acute allergies to the dust, and it's a strong correlation. Whenever there's a huge dust visitation, the allergies act up. So that is clear, I think. But the forecasting helps a lot in terms of precautions that can be taken.
Can I add something, Marvin?
Yes, you wanted to say something, Dr. Lazaro?
Can I?
Yes, please. Go ahead.
Thank you. Okay, I would like to clarify that most of the symptoms that the people are suffering with when Saharan dust arrives to the Caribbean are mild symptoms, right? So we're not saying that a lot of people are dying. This is not a powerful hurricane. This is not tornadoes, but indeed, we're seeing, we have been reading also evidence, and we're analyzing the evidence that in this is affecting the health of the population. Thinking more not in the general public, everybody, in the healthy people, I don't know, young people between 25 to 45 years old, athletic, but thinking more in sensitive groups, people that have pre-existing health conditions, elderlies, young children, people with asthma. So thinking in those vulnerable groups is why this kind of tools are very useful, right? Obviously, healthy people in the general audience can take advantage of this, and they can have benefits also, but the people that will benefit the most are those that are inside of those vulnerable groups, and that's the difference. So having empathy for these kind of people that are getting affected because they're more fragile to these kind of events, and make this kind of tools successful.
Sure, thank you so much. All right, so I'll now direct a question to the panelists, because one of the outcomes we wanted to identify was, in your opinion, what would be a significant research gap that you think the Caribbean needs to address in looking at air quality in the Caribbean? So I'll start with you, Dr. Lazaro, if you have a thought on that.
Yeah, wow. One of the things that we have been noticed working together, based on our experience working with the Department of Health and the National Weather Service, has been how to manage the infodemic and the misinformation and the disinformation in the media. I don't know, Andrea and Kishan, if it happens in your country during the DUS event that it came a couple of days ago, that it also came with SO2 from the Las Canarias, from the Canary Islands, bringing sulfates to the region. But it generates like a collective hysteria in the social medias of Puerto Rico, because they were using some kind of satellites that are very useful, yeah, but we still lack of the ground-based information to inform the population what indeed we were looking at, right? But a lot of people start now. Kishan was saying that the Saharan dust now is now in the media. Every day you are seeing in the weather people talking about Saharan dust. That's great, but also the issue is that also the social medias are talking about these kind of things, like they know what they're talking. And many people are saying things.
All right. So,
and the general audience is getting scared. So risk communication is a challenge, because we're bringing a new topic, if you want, about health, and we don't know how to control these kind of things. Risk communication is a real challenge.
All right. Thanks so much for that response. Unfortunately, I can't go on to Dr. Kumar Singh or Dr. Saylor because this session is at an end based on the time. I'd like to thank you all for your participation and to thank the audience for their participation as well. So colleagues, have a good day.
Thank you very much.
Thank you. Same to
Yeah.
you.
Sorry.
Bye-bye.